In this program, we're going to take a look at some different ways that we can declare members, and the main reason for this is going to be a space saver, but we can do some cool tricks, and we'll finally begin to find out what this word static means that we've been using the entire time we've been using Java. So what we'll do is we'll construct the entire main program first, and then we'll solely be focused on writing the class. So what we'll do is we're going to have three different pies. So pie cherry is going to be here's new pie, and we will give it the name cherry. And the two pieces of data here are one, for how many slices of that pie there will be. So there will be 8 slices of the cherry pie. And then the diameter. So we typically refer to a pie in terms of like how many inches diameter it has. Same thing for pizzas. This is going to be a 10-inch pie. And then we'll have, maybe I'll copy and paste. Then the next pie is going to be, let's put a raisin pie here. So raisin. Now we're going to keep this one identical. And then the last one is going to be a lemon pie. So we'll change the name. This one will have 6 slices and will be an 8-inch pie. Okay. This might seem strange. We're going to put a system.out.println here, and you'll see why in a minute why we're doing that. Now what I'm going to do is I'm going to sell some number of slices of each of these pies. So we'll have cherry.sell. We'll do 2 slices of that one. Then raisin.sell. We'll do 1 slice. And then lemon.sell, we'll do 8. And you can see that 8 is larger than the actual number of slices that we have of that pie, but we'll work around that in our sell method. And then we'll put another system.out.println here to get a blank line. And then what we'll do is we'll put 3 system.out.println lines here for the various pies. And it will be revealed what these different sections will be doing as we create the class. So that's raisin, and this will be the lemon. Okay, so now what we want to do is sometimes when you have this scenario where you've got all of the methods described in the main program, but you don't necessarily want them to run yet, what we can do is we can turn various sections of this into comments, and then when we get them figured out in the class, then we can unlock them and then they'll begin functioning. Okay, so now let's go and create the class. So this is going to be pie.java. Now here, just so that we don't have to come back up to the beginning of the program again, we're going to use number format a little bit later here. So import java.text.number format. And here is the beginning of the pie class, and we will have several members for this one. We'll be creating them as we go, and then our methods will be underneath. Okay, so the main ones here we've got to figure out. So private string name, private int slices, price, private int slices. Now we're not actually going to have a diameter for this because typically when we're doing calculations, we don't use the diameter, we use the radius. So we'll have the radius for this one instead. So now, we're also going to have private final pi. So we're going to do an area calculation here. And we'll have that as 3.14159. And we need to put its type here as well. That's a double. And then we're ready to begin our constructor method. So public pi. Now the three values I'm getting here are the string n for the name. We're getting int s for the amount of slices. And then we'll get double d for the diameter. And then we'll set those values. So the name is going to get the value n. The amount of slices of this pi is going to get the value s. And the radius is going to get the value diameter divided by 2. And then we'll be more prepared to do our radius calculations. Okay. So what we're going to do here is, as part of the constructor, we're actually going to have an output, which is not commonly done, but I just want to demonstrate that it's totally okay to do this. So we're going to have a println here, and let's put the name of the pi plus pi has an area of plus pi times radius times the radius. I'm not going to worry about units here. This is just for the purposes of demonstration. So now if I run the program, we get the area of each of those pies based on their diameter or their radius. So here's the first optimization for our program that we are going to do using static members. So what I want to do is I want to take a look at these various things. So now when we have a name, its size is based on length. So each of these pies needs a name, and it's going to take up space in our program. It's going to allocate memory based on how long those names are. Now, an integer is 2 bytes of data. So we have 3 values, so that's going to be equal to 6 bytes altogether. And then our radius for this is going to be, now a double is 8 bytes of data. So 8 bytes times 3 is equal to 24 bytes. And this is the pi value is also a double. So that takes another 24 bytes for our program. So now imagine that instead of 3, we had like 30,000 of these. All of a sudden that's going to start to take up a lot of space. So if I put in 4 zeros, this is of course fictional, and I'd have to do this for all of them. All of a sudden, it's starting to take up a little bit more space, and then we want to maybe maybe we've got 1 billion pies, and this is where we want to see, okay, is there a way to make the allocation of data a little bit more efficient? So what we're going to do is we are going to target this pi value. So the issue that we're having here is, okay, each pi will need its own individual amount of slices because they're all different. Each pi will need its own amount of radius. Each pi will need its own name because each of those elements are individual for those objects. However, pi every single pi we create is going to have the exact same value of 3.14159. So this seems really inefficient that we would have 8 bytes multiplied by however many pi's we have. What we want to do is we want them all shared, and we want to cut it down to just 8 bytes. So what we're going to do for this is we are going to include the word static. So what static means, static is one value shared by every instance of type pi. So every single pi we have is going to share this one value. So instead of 240,000 bytes, it's going to only take 8, in this situation where we have 30,000 pi's. So we have just made a massive, massive improvement on the efficiency of the memory allocation of our program. And we can see that if we run it, everything is exactly the same. There's no change here. Okay, so that's the first main thing that we're going to do. Now, let's handle the cell method. This one won't really include any static data, but we need this one. So public void cell int s in this case is how many we are selling. So if the amount of slices minus s is larger than 0, so if after we reduce it by the amount that we're selling, we still have a positive number of pi slices, what we're going to do is we're going to display things like this. So system.out.println s slices. Now, I guess it's not guaranteed, it's a plural, so we'll put that in parentheses, of name plus sold. Okay, now we'll actually reduce the amount, so slices gets the value of slices minus s. And then we will display system.out.println slices plus slices remain. Okay. Now we want to handle the alternate scenario where there are too many, or potentially, an amount that will reduce the amount of slices to 0. In that situation, I'm just going to adapt this thing here at the top. So in this case, all slices of, slices of whatever pi this is sold. Maybe we'll put the word pi in here. Make a little bit more sense. And then what we'll do is the amount of slices will become 0. And we'll put a sold out message here. So sold out, exclamation point. All right, so now that we've got that, we can unlock this section of the main program and we can see what we get. So I'm going to run this again. So now we've got our area. It tells us how many were sold, how many remain, and so on for all of them. So now what we're going to do is we are going to construct the toString method. And this is going to include a few extra cool things that we can do with static variables. So public string toString. All right. So the first thing that we're going to do is we're going to use a percentage here. So we're going to represent how much percentage the slices of this pie are compared to the total amount that we started with. So we'll start with a number format. Number format percent gets number format dot get percent instance. There we go. And then we'll have a string display, which we're going to make. And then we'll have a double representing how many pies are remaining. So now what we've got to do is we've got to figure out how many pies of the total amount of pies do we have left over. So what I'm going to do here is I'm going to create another static member that's going to act a little bit differently. So private static. And we're going to call this one total slices. And this one's going to keep track of how many slices we started with. So we're going to start that at 0. And here's how it's going to work. After we set how many slices there are for an individual pie, we are going to go total slices, and we'll add on the number of slices for this individual pie. So what's going to happen is, and I'll take a look at the main program. So after we construct this first object, total slices is going to have the value 8. Now, because it's static and this is shared, so we have one, keep that as an integer. Because we have one single variable that is shared by every single instance of pi, after we create this second one, it is going to add on the amount of slices to our total slices. So after this one, our total amount will be 16. And then after this last one, our total amount is going to be 22. And this is a little trick that you can do with static variables. So we can accumulate how many slices we have as we create these things. So we're going to use that down here. So the amount of remaining pies is going to be equal to, now we'll typecast slices as a double so that we actually get a decimal out of this, divided by total slices. And then what we're going to do is we are going to construct our display. So display, we're going to start it by putting the name plus pi has, this one's going to be a little bit complicated here, lots of things added together, slices plus slices left. And then the second part we're going to do is we'll put display plus equals percent dot format remaining, and then we'll say of the total initial amount. I don't know why we would keep track of this value if we had a pie shop, but it's just to illustrate something that we can do with static variables. So if I run this, oh, what have I done? Oh, I didn't return statement. So let's return the display now that we've created it. So try that again. And now that we've got that, I will unlock this from the main program, which I forgot to do. And here we go. Now we'll get the this displayed. Okay. So what we get is how many slices are left of each pie and what percentage that represents of the total initial amount of pies that we had. So these six pies represents 27% of the original 22 slices we have. The 7 represents 32% of that 22 slices, and obviously the 0 lemon pie slices represents 0%. Okay, now what I want to do is, this is a little bit like a list. I would really like to have these numbered, 1, 2, 3. And we can do another cool trick with static variables to get that to work. Okay, so just like total slices, we're going to keep track of private static int total pies. We'll start that at 0. But we're never going to display total pies. We're going to do something cool with it. So every time we create a pie, here's what we're going to do. Step 1, total pies plus plus. So every time we create a pie, we're going to add 1 to the total pie value. Now, the next thing that we're going to do is we're going to set the number for this pie that we are constructing. So we need a new variable for this, so private. Now this one isn't going to be static because each pie will have its own number, and we'll call this one pinum. Okay, so what we're going to do here, and really think about this because this is something that people have typically a difficult time understanding. Our pinum is going to be equal to total pies. Total pies. That's right. Okay. So now what we're going to do down here is we will add the numbering onto our display. So we're going to start with pinum plus, and we'll put a little parenthesis divider there, and then I will run the program. There we go. So now they're numbered. Now, if you don't understand why it did that, that might seem a little bit magical. So let's go through so I can explain what just happened. So we've got total pies, and total pies. Okay. So what happens is, and remember that every time we create a pie, every time the constructor runs, it adds 1 to the total pies amount. So it adds 1, and then the pie number of this individual pie, notice it's not static, so the pie number of this individual pie becomes whatever the current tally of pies is. So what happens here is after we create our cherry pie, the total amount of pies is 1. And then the pinum becomes whatever the current total is, which is why this becomes 1. Then what happens is the raisin pie gets constructed. Now we have 2 pies, and the pinum gets set to whatever the current total of pies is, which is 2. And then we get the final lemon pie. The total amount of pies is 3, so the individual pie number that we have becomes 3. So by creating static variables, not only can we save a ton of space, especially if we have a lot of instances of this class, but we can also do some cool tricks in terms of like keeping track of values across all of the instances, and even using it to set things like as we're constructing them. So these are pretty cool, but they are maybe a little bit trickier to work with, so we'll see some other examples of this as we go.